Okay, hello everyone. I hope you can hear and see me. Hello from the UK. My name's Alistair. I'm a games designer, and this is my channel Playful Technology, where I create interesting, playful electronic projects. Oftentimes they're for puzzles used in escape rooms and things like that. Now, what I normally do is each month I upload a project and I put a video on YouTube, and then I put some downloads and things like that on Patreon. This month we're going to try something a little bit different in that this is a live tutorial. So hello everyone watching live. This is your chance to ask me questions as we go along, make comments. If there's stuff that I don't always remember to explain very well, or if there's particular things which I forget to mention, or anything you really want to know about, I'm keeping my eye on the comments window on the side there, and with a bit of luck I will notice and be able to address them. So that is that out the way. Everyone seems to be able to see and hear me okay, which is good. I can't actually see myself. For some reason my preview window is not working very well. So do shout or type if I don't notice it, and I'll see what I can do. Okay, so here we go. What we're going to do this afternoon or this morning is create this. So this is a basic sort of bare bones setup for a fairly typical escape room puzzle. What I've got here on the board is I've got an Arduino at the top. This has got a single push button that's going into it. I've got a relay here, and I've got a maglock at the bottom. Okay, now these are all components which I've used in previous project videos. They're possibly components that you are familiar with as well. So the first thing I'm going to do is kind of talk through each one, what they're used for, how they're connected together, why they're used, things like that. And then I'm going to show you the code, which I'm going to upload to the Arduino, and then with a bit of luck I'm going to show it working. So the reason why I've chosen this puzzle, I mean, it's not much of a puzzle to be honest. What's going to happen is this magnet at the bottom here is going to have a iron bar secured to it by default, and when players press the push button at the top, the bar is going to be released. Not much of a puzzle, I'll grant you. But the point of this is that it demonstrates the kind of the flow in which most escape room puzzles work. We've got an input. Now the input here is just a push button, but this input could be replaced by, for example, a light detector. So players need to shine a torch at it to activate, or a laser detector, or a microphone that they have to sing into, or an RFID. Yeah, there's loads and loads of different inputs you can use. I've just used a button because I think it's the simplest one to understand. But we start off with players doing some sort of input, okay? And then at the bottom of the board, I'm using a maglock here. Maglocks are very commonly used in escape room as an output. So this is a physical way of securing a door or a drawer or a chest of some sort, things like that. It is an obstacle which players cannot proceed past until they've solved the puzzle. And at the end of the day, that's what escape room games are. There is a series of obstacles that you have to overcome, and it's, you do the right input, you get an output from it, you normally use that output in the input for the next puzzle along, and things like that. So my output here is a maglock, but again, you could very easily swap that out to be any sort of, it could trigger a video display, it could be a motor or a linear actuator that makes something rise up. The relay here, I'll talk about that in more detail in a bit, but that is a switch which is going to enable the Arduino to control whatever this output is. And then the Arduino itself is the logic, the processor, the thing that is connecting the input and the output together. And that's the thing that's going to define the rules that says, what do players have to do with this input to make this output work? Okay, so that's the whole setup on the board. I'm going to sort of go through each of those in more detail. So first, let's start with the Arduino, because most of my projects use Arduinos. and I'm not sure I've ever really explained exactly what an Arduino is or why I use them. So let's start with that. I'll just put that board down for a moment. So I've got a standalone Arduino here. This is an Arduino Nano. You can also get Arduino Unos and Megas, which are bigger and have slightly more pins. And you can also get very similar boards made by different manufacturers that essentially do the same thing. So what are they? When you think of electronic and tech projects, you kind of think of hardware and software, really. So your hardware is things like your magnets, your lights, your switches. And it's easy to imagine an electronic circuit being formed by a series of pieces of hardware plugged into each other. And it's kind of a fixed sequence of operations that happen. And then when you think of software, you probably think of computer code that has variables and input from a keyboard or something like that. And so it's something a bit more dynamic, but it's also less tangible. And the point of an Arduino is it kind of bridges the gap between software and hardware. So it has a number of these pins on the side of it. These are called general purpose input-output pins, or GPIO pins. And they can be used to control inputs or outputs, hence the I/O. And the way in which they can control them, though, is programmed through software that you upload onto the chip. So this is a hardware controller, but it is one that you can change its behaviour through software. So it's a little bit like being able to kind of rewire your circuit, make it behave in different ways. But rather than having to pull out wires and change the way that components are connected to each other, you can do it very simply by uploading new code onto the chip here. And this is going to change the way that the inputs and outputs plugged into these pins are routed to each other. So whenever I say the word Arduino, I mean, I'm using this particular device, a Nano, but there are many other similar devices. You upload the same sort of code to them and they behave in different ways. I'm using these because I've just got a whole bunch of them. They're cheap and they're easy to get and things like that. But you can use other similar devices in other ways. Oh God, just dropped that on the controller. Hope I haven't crashed anything there. So this is the push button I'm using. So buttons are a very straightforward input mechanism. That's why I'm using it. This has a spring button on it. So this is what's called a momentary push button. So what that means is that it's in a state at the moment. When I press the button down, it changes state. And when I release it again, it goes back to how it was. So compared to a toggle switch, which has two states and you move the toggle between them, this one is only momentary in the sense that it only changes state for as long as I continue to do something to it. So that's what we mean by momentary push button. And this has 3 connectors on the end of it. This one's a little bit bent down. And I will attempt to show you the markings if I can on the side of this. I'm not sure if you'll definitely be able to see those or not, because I have no idea what you can see. But it has one terminal which is called a common terminal, and it has these 2 terminals here, one of which is called normally open, and one of which is normally closed. So again, when we talk about electronics, when we talk about normally closed, closed in that sense means connected. So the normally closed connector here is normally connected to the common connector. And the normally open one is not connected to anything. So open means not part of a continuous circuit. Closed means it is part of a continuous circuit. When I press the button, the connector that was normally open now becomes closed, and the one that was normally closed now becomes open. So it's like it is a switch. It changes which one of these 2 is connected to the one at the bottom. Okay, and we'll read the state of that on the Arduino later. Right, the next component I've got is the relay module, and I've got another one here. I haven't even got this one out of the packet yet, so let me get this out of the packet and we'll see. So I am using a relay module that looks like this. You can get these very easily on eBay or Amazon or AliExpress or all those places. And it literally costs like $1 or $2 or something like that. Now, when I first started learning electronics, I have to be honest, relays confused me because I couldn't quite see what the point of them was. So a relay is an electronic switch, okay? So, a light switch is a mechanical switch. You physically move something and it connects a circuit. The momentary push button here we just looked at is a mechanical switch as well. So when you physically press something, it changes a electronic connection instead. Now this is an electronic switch. So depending on an electrical current supplied on one side of it, it makes an electronic circuit on the other side of it. And for a while I was like, well, hang on a minute. If you've already got electricity going into this side of it, why do you have to use that electricity to turn this electricity on? Why couldn't you just kind of use the first electricity? If that makes sense. So the reason for that is, going back to our Arduino again, so our Arduino can send a small amount of current through any of these pins that are marked as output pins. So we could set pin D8 here, which is just halfway along this edge here. We could set this as an output, and then we could write a high signal to it. What that means is that that pin is going to have 5 volts of potential compared to ground. So when we talk about high signal on an Arduino board, what we mean is that it's always relative to ground. Ground is like your 0 baseline. If something is low, that is equal to ground. So the difference between a low pin and ground is 0 volts. The difference between a high pin and ground is 5 volts. That's assuming you're using a 5 volt Arduino like this one. There are certain models of Arduino, like the Arduino Pro Micro. That's a 3.3 volt device. And Raspberry Pi is a 3.3 volt device as well. So if you're using one of those and you write a high signal to one of these output pins, you'll get 3.3 volts above ground. Okay? So it's quite a low voltage. And the other thing is, you can only draw a very small amount of current from any of these pins. So it's enough to light an LED, and it is enough to switch an electronic switch, like a relay as well. But it is not enough in itself to power something like this maglock here. This is a 12 volt maglock, so it needs 12 volts of power. And I think this one draws about 150 milliamps of current as well. So it needs more current and it needs a higher voltage than the Arduino itself can supply. That's where the relay comes in, okay? So the Arduino switches the relay. This mechanical switch inside here clicks on and off. If you've heard a relay activate, you can hear it click. So there's little metal contacts in here. And what that does is that allows this 12 volt supply, which I've got coming in here. You possibly can't see that, but that's just like a 12 volt power. I think Americans call them wall warts, like a power pack, power plug, whatever you want to call it. It's 12 volt DC supply coming in here. And that's what's powering the maglock. So we've kind of got 2 different circuits going on here. We've got the 5 volt one at the bottom. Oh, crikey, sorry, all my labels are coming off. The 5 volt one, sorry, is powering the Arduino. It's powering the power side of the relay. And it's what we're using to compare whether the button's been pressed. And we've got 12 volt that's happening at the bottom. That's being switched by the top circuit. Okay, has anybody got any questions about any of that so far? Let's have a quick look at the comments on the right hand side. Let's scroll down that. No, is that all making sense to everyone? I hope that's all making sense to everyone. Cool. Okie dokie. So, if that's the case, what we'll do now, so let's talk about how I've wired these components together. I've talked about individually what each one of them does. Now let's talk about how they work together to sort of make something that does something useful. So, my button, I have got, although I talked about it having only 3 contacts, I've only wired 2 of them in, you'll see. So I've wired the common connector, and that is going to my digital pin 2. And then I've taken the normally open connector, and that is going to ground. Oh, okay, we've got a question. So I'll come back to my button in a minute, but we have got a question about the relays. So, yes, the relays for 3.3 volts and 5 volts are different. And this is something, it's another thing that people can get tripped up at by. So, this relay that I'm using here is described as a 5 volt relay. In fact, if I hold this one up to the camera, I'm hoping you can see the second line down. So it says Tongling, which is the manufacturer. The second line down says 5 VDC, so 5 volts DC. That is describing the power that is used to energize the coils in the relay that's actually going to switch it across. And it also is the power that the signal line is going to be used to compare to decide whether to switch the relay on or off. I'm sorry, I'm trying to catch up with comments at the same time. So for a 5 volt device like an Arduino, I'm using a 5 volt relay. If you're using a 3.3 volt device, you might still be able to use a 5 volt relay though, because when we're talking about high and low signal, it's not an exact value. When you write high on a GPIO pin, you're not actually getting exactly 5 volts. You might be getting 4.5 volts. And when you write low, you might not be getting exactly 0 either. So there's actually a sort of a threshold above which a signal will be interpreted as high, and there's another threshold below which a signal will be interpreted as low, and there's kind of a bit in the middle which is sort of ambiguous. So with a 3.3 volt device, if it is actually sending 3.3 volts exactly, that will probably still be regarded as high by a 5 volt system. But it might not be sending exactly 5 volts. So you can get lower voltage relays, and you'd probably want one to match your system. The other thing you can do is you could use what's called a transistor before the relay. So you've got your low voltage, low current output from your 3.3 device. That goes into a transistor, which is again a bit like an electronic switch. When it's supplied with a certain voltage at a gate, it allows a bigger voltage to go through the other 2 pins. It's a 3-pin device. That could go into the relay to switch to 12 volts. So, yeah, you want to get one that matches the output levels of your device. Yeah. If you find the required voltage in the specs, yeah, it should be a regular phone. It needs to be conversion to male plug to 2 wires. Is there a specific power supply I use for the maglock? Okay, so hang on, let me just, literally, this is, so I'll unplug it just so I clear. This is the power supply I'm using for the maglock. I genuinely can't remember what this came from. I think it might have been from like a camcorder or something like that originally. But the things to watch out for, so obviously I'm in the UK, so our mains power here is at 230 volts AC. So you want something that's got an input that matches wherever you are in the world, and the output to look for. So I've got DC output, it says 12 volts at 3 amps here. Now that's plenty for the maglock I'm running. You need one that has the same voltage as the maglock you're running. Most of them are 12 volts, some of them are 24 volts, and at least as much current as the maglock's going to draw. I'm using quite a small maglock, so this is only about 200 milliamps. Bigger maglocks might maybe half an amp, something like that. But so long as you've got something that has the right voltage and at least as much current as is going to be drawn, you can use whatever power supply you want. So I'm just going to plug that back in. Okay, where was I before that? We were talking about... okay, I was talking about the button. Maglock I've got shows a working voltage and current of 12 volt with a 12 volt. Yes, that's fine. Yeah, who's that? Tanya? Tane? That's absolutely fine. So if you've got the right voltage and at least as much current can be supplied by your power adapter, that will work for your maglock. Yeah, that's fine. So, buttons again. So I've only wired two of the buttons in. I've wired the ground and I've wired the normally open, and I've wired them to the input pins. Now, the thing about buttons is what you might think, and it's kind of what's easy to think normally, is if I'm reading an input pin here and the button is up, let's say, or the button is down, then one of them must correspond to high and one of them must correspond to low, because those are the two states that we know digital signals can be in, high and low, 5 volt and 0. But if you recall what I was just saying about the relay voltage and the 3.3 devices, that's not quite true. When the button is not being pressed here, it's not actually high or low. It's what we describe as a floating signal, and this is a floating pin then, the one that's connected to it. Because when this button is open, remember I said that normally open is not connected to anything when the button's not being pressed. So if we tried to read what this digital pin here is reading, it's not connected to ground, but it's not connected to 5 volts either. It's just going to be somewhere in the middle. And so that's not very good. You would have your signal triggering and you wouldn't know what's going on, and then maybe if you brought your finger close to it you'd find it triggering. That can be a lot of problems that people have in controllers sometimes if you haven't properly grounded your system. But this pin here, I'm going to use something called the pull-up resistor, which is inside the Arduino. So what that means is that inside the chip here, imagine like a tiny, tiny little resistor. All of these pins have them connected to them, and you can activate them through code. So remember, the whole reason for using an Arduino is that we can effectively kind of rewire the way the system works just by changing a few lines of software code. And when we define this pin as an input pull-up rather than just an input, what it means is that when nothing else is happening on that line, it's going to be connected to 5 volts through what's called a pull-up resistor. So the resistor is going to provide a little bit of load, just so that it's got so the circuit has got something to travel through, sort of thing. And the resistor is going to go from there through this resistor to 5 volts. So when you do a digital read now of this pin, it's not connected to anything here, but it is connected to 5 volts, and it's going to read a high signal. When I press the button though, now what's going to happen is it's still got that connection to 5 volts, but that's going through a resistor. What I've got here is that I've now got a direct connection through to ground. And if you remember from kind of electronics days at schools and things like that, you know, electricity will naturally flow through the path of least resistance. That's why we have that expression, the path of least resistance. So it could either go through a resistor to 5 volts, or it could just go straight through this circuit, it's got no resistor in at all, through to ground. So what we've got now is that when this button is pressed, this signal is going to go to 0, or a low signal, because we're connected directly to ground. When it's released, it's connected through a resistor, but to 5 volts. So that's what's going on there. And again, that can be a tricky point for some people, because you sort of think, well, hang on, when the button's pressed, that would be the high signal. When it's released, that would be the low signal. But it's not. It's the other way around. So that's all that. My relay over here. So I've got 3 wires going to the relay here. I've got my ground again. So pretty much any module you end up connecting to an Arduino in any project like this will almost always have a ground connection and probably a 5 volt connection, because most sensors you're likely to use will be 5 volt powered. So that just means that every device that you might end up using, so whether it's an amplifier for a sound system, or whether it's some sort of sensor or an LED or anything like that, they've got these common reference points they all have what's called a common ground. So when we define a low signal, they all think that 0 volts is the same 0. So you imagine it's like calibrating your system, basically saying, you say, okay guys, this is what we're going to call 0 volts. Can we all agree on that? That's why you have a ground that connects everything together. And then you normally have a 5 volt as well, and that's defining what your high reference point is. So you're saying, okay, we've got ground established, that's what we'll call low. Now let's set 5 volts. That's what we call high. And then everything can kind of talk to each other using these common frames of reference of what we mean by a high and a low signal. So my relay has a 5 volt and ground connected. And then it has this third wire, this yellow one, which I've got going into A0. That's the signal line. And that's what's going to switch the relay switch on or off, depending on whether it's ground or 5 volts. So 5 volts is always 5 volts, ground is always 0 volts. This one here, I'm going to switch between them, and depending on which one of these two it compares to, that's what's going to turn my relay on or off. And that is what's going to connect the 12 volts to the maglock at the bottom. I'm just going to release my thing. Okay, if no one has any other questions about the hardware, what we'll do now is go on and look at the software then that's going to make all this work. So I'm going to load up my Arduino IDE, hopefully. This is the point where the tech becomes really interesting. Bear with me. Okay, if I do that and shuffle to the side slightly, I'm hoping now you will be able to see my Arduino IDE window. So this is, oh hang on, I've just got a question about relays. If you're using a 5 volt power supply for the Arduino and 12 volt power supply for the maglock, do you ground them both together as well? Okay, so that's a great question. So I have got two separate devices here. I've got my 12 volt DC coming in here. I've got my USB, which I'm using to program the Arduino, is also providing my 5 volt power supply as well. I have not connected the two grounds because they're effectively completely separated at the moment. My relay has something in it called an opto-isolator. So the way that there's a little bit more complexity going on in here than I explained. But what's happening effectively is my 5 volt signal is causing an infrared LED to light up inside here. When that is detected by an infrared detector on the other side, that's what's turning the 12 volt signal on. So there's actually a complete separation of these two circuits because there's an air gap here. It's just an infrared light that's being shone that's what's turned this on. So I don't have my grounds connected here because these are being treated as two completely different circuits that have no dependence on each other. If, however, I might have a different 12 volt device, however, down here that for some reason, I'm trying to think of an example, can't think of one, but let's say that I had a different 12 volt sensor that was interfacing in some way with the 5 volt circuit, then yes, in that case you would want to share the grounds together. So we call it tying the grounds together or sharing the ground, because again that establishes that common reference point of 0. That means that from there everything can be referenced to the same sort of place, if that makes sense, hopefully. So I don't have my grounds tied together. These are completely different circuits, but sometimes it would be correct too. I think that kind of answers it. Okay, you can see, thanks. Wait, we can see the Arduino window, excellent. So, okay, so let's type some code. And this is always fun to do live as well because there's this massive chance that I'm going to mess this up. So, there is no universal coding standard of the correct way to write Arduino code. I mean, I have a set of kind of habits which I've built up over time. You might have your own habits. I'm not going to say that anything is better or worse than others, but this is the way I do it and I find it works for me. So I'll share with you how I do it and why I do it that way. And you know, hopefully you can adapt that or adopt it if you want, or you can ignore it if you want. So I always divide my code into sections, and the first thing I do at the top is what I call my defines section. So a define is when you start with a hash and then you write define, and this is a little bit like a keyword. So I'm defining a keyword called debug here. I tend to do this at the top of all my code. The reason for doing that is that then later on in my code I can write something like if def debug. So if defined, that means debug. And I can write something else here, and then end if. So this is what's called a conditional code block. So this is only going to get executed if this line at the top is there. So I can write lots of extra code that says, okay, I'm trying to work out what's going on with the system. So while I'm testing it still, I want to kind of throw out lots of information to the serial monitor, and I want to do this, or I want to make this light flash every second just to make sure I know it's still operating. So I'm going to put all that kind of stuff inside these code blocks that say if defined debug. And then when I'm happy that everything's working, rather than going through my code and kind of deleting those lines, which potentially I might make a mistake and delete something that was important or something like that, what I can do is comment out that line at the top. So putting two strokes like that is a comment, and it means that that line will no longer be executed by the compiler. And from then on, anything that says if def debug won't be active in the code either, because it's no longer true. There isn't a line that says debug anymore. So I always start with my definitions, and I normally just put a little comment to say that that is where my definitions are going to be as well. Okay. Next up, I tend to always put constants. So constants are things which don't vary, surprisingly enough. Typically in a piece of code like this, your constants are going to include the pins that you wired each of your bits of hardware to. Because unless you're creating quite a complicated ER game where players are actually physically rewiring the system halfway through, the chances are that that is not going to change throughout the duration of the puzzle. So in this case, we've got two buttons that we need to define. We've got the button pin, and that was plugged into number 2 at the top here. So I'm going to call that digital pin 2. And we've also got the pin that the relay is plugged into. Now that is going into A0. So a couple of comments on those points. Can I move a tiny bit to my left? Right, okay. Okay, so a couple of points to explain about those ones there. So, first of all, the const keyword at the beginning. That is telling the compiler that this value is not going to change throughout the duration of the code, and that means it can kind of move it to the right part of memory. It can kind of store it and say, okay, this is never going to change, so I'll just store it over here. Whereas variables are stored in a slightly different part of memory. You don't need to worry too much about that, but that's what the const bit means at the beginning. It's telling the program this is never going to change. Byte. Now this is an interesting one. So byte is telling Arduino what kind of value we're about to store. Now you might have seen code in the past that has int there instead when you define pins. So an int is an integer, a whole number, and obviously the pins that we're using are whole numbers as well. But I've only got, whatever it is, 32 pins on my Arduino or something like that. So the only possible values I can have are going to be 0 to 32. An integer can have a value of something like minus 32,768 to plus something. It's a very big range. And because of that, it actually occupies quite a lot of memory, because it's a value that can be very large, and it can also be negative, and we don't really need that much information. We're only going to store the number of a pin that's going to be used, and that's going to be a value between about 0 and about 32, depending on exactly which Arduino you're using. So I define them as byte instead, because byte is the smallest, a smaller variable type, basically. So it can still hold numbers in it. It can hold the numbers from 0 to 255 in it, which is enough to define all the pins on an Arduino. So that's why I use byte rather than int. Int would work as well. It's just, it would work fine. You almost certainly wouldn't notice the difference. But just from a kind of a coding best practice, you really want to use the smallest type of variable you can do that's going to capture all the information you need. And at the moment, that's byte. So we define our two pins. Two separate. There we go. That's fine. The next one is obviously what we're going to call it. So I'm calling them button pin and relay pin. I cannot emphasize enough, please, 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 name your variables something that makes sense what they are for. Don't call them like pin 1 and pin 2, or just my pin, or just my var, or something like that. It just makes it much harder for yourself, to be honest. It doesn't use any more memory to use a longer variable name there, because that will get ignored anyway. So you can call it something really descriptive. Excuse me. So I call button pin and relay pin, and I tend to include pin in the name because then I know what it is it's telling me the pin that's addressed to something. So that's what I've got there. And then I've just got equals 2 equals A0. So those are the 2 pins I'm using. A comment on the A0 finally. So the reason it's got an A in front of it is because that's one of the pins that can be used as analog input. When I said that these were general purpose input-output pins, which they are, but some of them have special functions as well. And a handful of them can be used for what's called analog input. So rather than having our button, which is just on or off, an analog input would be something like a dial, which can have a range of values, normally between 0 and 1023. And they're the pins along the bottom here. So I'm using pin A0. I'm not using it as an analog input. I'm actually using it as a digital output. But that doesn't matter. But that's why it's got the A in front of it, is because it's it can be used as analog input. Excuse me, I'm going to have a drink. Right, cool. Okay, so there are pins. There are constants. They're not going to change throughout the duration of the code. Now we go into our setup function. So setup, as it says in the comment that came there, setup runs once at the beginning when the device is first turned on. If you do reset your device by pressing the little red button on the top, it will run setup again then as well. So this is where you put stuff that you want to only happen once. And for us, what we're going to do is we're going to say what our pins are for. So we've got 2 variables, button pin and relay pin, and we know what pins they relate to, 2 and A0. Now we need to tell the code, okay, well, what are we going to use those pins for? So we're going to say that the button pin is input pull up. So remember, that's what I described earlier. That's saying it's going to have an input coming into it, but when there is no input, when that pin is floating, let's pull it up to a known value, which is going to be 5 volts for a high signal. But in contrast, our relay pin is going to be an output. And the other thing is, when this puzzle starts, I want the maglock to be locked by default. I want to press the button to release it. So having defined the relay pin as an output, I'm then actually going to write a high signal to it. So that is going to activate the relay when the puzzle is first started. It's going to secure the lock, and then the game is ready to play. So that's it for setup. And now we go on to loop. So loop is the section of the code that goes round and round and round and round forever. For as long as power is supplied to the Arduino, it's just going to keep on running that section over and over again. So actually, as it happened, I don't really have any debug code, so I'm just going to get rid of that. But that is what you would use it for. So what I need to do on every iteration through the main loop of the program, what I need to do is work out whether the player is pressing the button or not. And so I'm going to create another variable here, and let's call it button is being pressed. So the type of this variable is a bool variable. So bool stands for Boolean, and Boolean logic is true or false. So this is the simplest type that can describe whether the button's being pressed or not, because I can't half press this button. It's either on or it's off, so it's a bool value, this one. And we're going to get that by reading the button pin. So digital read is going to say, okay, let's look at the voltage that is coming in on that D2 pin, and is it high or low? And we'll assign that to this variable called button is being pressed. And then what we'll do is we will use the value of that variable to decide whether to activate the relay or not. So now we're going to write to the relay pin whether button is being pressed. So on this line here, so we've read our input, that was the first line, and now we're going to write our output based on what the input was. Okay, I think it's always a bit nerve-wracking when you're doing live coding, whether you've made any mistakes, but I think that's okay. So the next thing I'm going to do is check whether I made a mistake. So if you go to this tick box at the top, click verify, it's going to compile that, done compiling. Okay, so I haven't got any error messages, so that's a good start. And now I'm going to upload that to my Arduino. So I've got my Arduino plugged in. I'm going to go to the Tools menu, and I'm just going to select the right sort of Arduino. So if you ever have problems uploading to a board, if you get like an error that says something like cannot synchronize with board or something like that, a lot of the reason is maybe because you haven't got the settings in this bit correct. So I'm using an Arduino Nano, so I've got that selected there. The processor here, you might have different options here depending on which version of the Arduino IDE you're using. At some point in time, I had to start using the old bootloader method rather than new bootloader. Not quite sure why that is, and it probably depends on how old your Arduino boards are as well, maybe where you got them from. So I have to use old bootloader for this particular board here. It is quite an old Nano, to be fair, so maybe if you get a new one, you might just use the top option there. I'm going to select the COM port. I've only got one thing plugged in, which is COM3, so that all looks okay. With a bit of luck, here goes then. So if I click upload, so we'll get a little bit of sort of flashing going on over here. Done uploading. Right, okay, let's give this a whirl then. So with a bit of luck, it's a good start. Right, okay. I'll tell you what, let me just close that window down again so you can, there we go full screen again. Okay, so my prop is active, it's done uploading, and the first thing it does once it's finished uploading is it starts running the sketch. So setup function has run, it's defined all the pins, it's now going round and round that program loop each time, and what it's listening for is whether this button has been pressed or not. It'll assign it to that variable, and then if it is, it's going to release this maglock. So that maglock is on at the moment. I've put it on its side just to make it a bit easier for you to see. Normally you'd obviously have that flush on the wire there, but hopefully it's it. And what I'm really hoping is going to happen is when I press this button now, that's going to fall off. So let's see what happens. Okay, here we go. Hey! Perfect. Now I've released the button. If I put this back on again, yeah, it's locked again. Okay, so I can repeatedly, over and over again. Ow, thank you. Right, that's quite heavy. Even though it's a little one, that's quite heavy. So, there we go. So secure it on, press the button, and it comes off. So there you go. That's the complete thing. I'm just going to go and, because I've managed to minimise my window at some point, so I'm going to go back to my window so I can see your comments again. So the input button for the button, something about the wayward connector button like the one used in terms of yeah. I think a lot of it. Okay, so I'm just going to go over a couple of those points. Right, so let's start with input pull-up. Saying something about the way you connect a button like the one you did in terms of. So, input pull-up is a hard thing to get your head around, and it is related in a sense to normally open, normally closed as well. So, if I had wired my button here to normally closed and common, and I was using an input pull-up as well, then what would happen, let's get this right, let's make sure I tell you the right thing. So what would happen then is when the button is not being pressed, we're connected through the input pull-up to 5 volts onside the board, but we're also being connected to ground, which is a path of low resistance, so that's going to read low. When you press the button, you've broken the connection with ground that was here, but you've still got the you've still got the input pull up to high, so then it would go high. So yes, you're right. If you wanted to get the behaviour the other way around, you could achieve that by putting this into the normally closed rather than the normally open. Oh gosh, I think I've got that right. I mean, it's kind of habit really as to which way round you want to do it. So long as you're kind of consistently logical about saying normally closed and normally open and high and low. The other thing that goes wrong sometimes, sorry, my labels are all full of my board. So my relay, I have what's called an active high relay here. So when I was writing my setup code there, to lock the lock, I wrote a high signal to it. But you can also get active low relays as well, which are, surprisingly enough, the other way around. So for those, you send a low signal and it will switch to the normally open connection. So lows and highs and normally opens and normally closed can be a bit of a minefield, and you just sort of have to step through them sort of gradually to try to make sense. Or, you know, if it comes to it, if your code is behaving the opposite way round than what you thought it should be, swap your lows and highs around and they'll probably fix it. I think a lot of the Amazon clones use the old bootloader. Yeah, I think you're almost certainly correct, to be honest. Like I say, it probably depends on the supplier and perhaps the age of your device and things like that. It's an easy fix to just select the other model in the Arduino IDE. Can I explain bool again? Yeah, sure. So remember I talked about the different types of variables. So you can have an int, which is a number. You can also have a char, which is a letter. You had byte, which was a small number. That's the one that had 0 to 255. Bool is true or false. That's the only two possible values that a Boolean variable can have. So it's a really, really simple data type. It's very small. It doesn't take up much memory because it's literally represented by a 0 or a 1 on the device. So for things like is a button being pressed, a bool is the way that you would normally represent that. Again, you might see some code, some nefarious code on the internet you might find has an int value being used for whether a button's been pressed or not. And it'll have an int value 1 or an int value 0. Again, that will work, but you're kind of you're wasting memory by using an integer to store that, because an integer has enough space to store values like 32,000, and that can't possibly represent whether a button's being pressed or not. So that's the reason I'm using bool, is it's the simplest type of variable that you can have that can accurately represent all of the things of the state of that button. I pretty much start with the old bootloader, then if no, yeah, again. And when you have lots of different boards, say I have nanos and unos, and I also use ESP32s, and I've got some Wemos boards, so you end up with quite a list in that boards menu of ideas, the type of board you want to upload to. And I don't always remember to change it first time. I normally click upload a few times and it fails, and I go, oh, what's wrong with it? So I have to manually remind myself to set the right board. It won't do any harm if you have the wrong board selected. It's not going to do any harm. It will just fail in the upload, and you've got to select a new board instead. That's all. Bool stores either true or false. It's logic like binary. Yep. Int can store 1, 2, 3, or 4. Bool. Yeah. Thank you. You probably answered that question better than I can. So thanks for that. Is it normal for maglocks to get very hot after being on for a long time? Is there a certain brand you recommend? Okay, let's talk about maglocks some more. So I am using this maglock, which cost me, I don't know, like $8 or something like that, and it's got a lot of Chinese writing on it. So maglocks. This one, so when did I can't remember. This one is slightly warm to the touch, I would say now. I would not say it's hot, I would say it's warm at the moment. And that's to be expected, that's normal. So what's happening inside here, there's a coil which is drawing that current constantly through it. They will heat up, that happens. If you ever get to the point where your maglock is, really painfully hot, I would say something is potentially wrong that you might need to look at. The most classic mistake I know of with people using maglocks that get very hot or break is they're using a different style of maglock. So this is what's called a fail-safe maglock. And the point being, which I can demonstrate quite easily, where's my thing gone? Right, okay. So this is my fail-safe maglock, and let's just check. There we go. So if I put it back on, and now let's say there's some sort of power cut, okay, which I'm going to simulate by just pulling out my 12-volt connection here. When I do that, the bar has fallen off. And this is really important. So I'm not going to, I'm not going to tell you what the local laws are in your area or anything like that. I'm not going to say anything like that. I'm just going to say it from the point of view of being a sensible human being. If you are creating something that is potentially going to lock someone in a space, you need to make it in such a way that if anything goes wrong, they can get out again. Okay, so that's my health and safety bit over. So fail-safe maglocks do that. If there is a electrical outage for whatever reason, if there's something goes wrong with the software, if there's a fire, if there's anything else, the electricity goes down, the lock is going to release, someone's going to be able to come out. However, there are other sorts of maglock available which are called fail-secure maglocks. And they look slightly different. They have a like a catch normally, and sort of a loop that goes into a catch. And what happens with them is they're the opposite way around. So they don't normally have power going to them at all. They are just locked and they stay locked mechanically. What you have to do is you supply them with power to unlock them. So it's totally the opposite of the maglock I've got here. And the problem with them is, if the power fails for any reason, they won't unlock. They stay locked. So you must never, ever, ever use them to secure anything that someone could get locked in. They're fine for putting on boxes, or on drawers, or small cupboard things like that. In fact, they're very useful if any of you create portable escape room games. They're really good for that, because the point is that they can stay locked and use no power whatsoever, because their natural state is just to be locked. And then you supply just this brief amount of power, half a second, something like that. They kind of eject and spit this catch out, and then you can turn them off again. Now, if you leave the power connected, though, on those ones, after they've spat the catch out, they get very hot, and they break quite quickly as well. So you wire them the same way, but your code works a slightly different way, in that rather than just changing from high to low, or low to high to secure and unlock, you send like a pulse of power, eject the catch, and then immediately turn it off again. That's how you use those ones. If you leave them on, they get very hot, and they, like I say, they break really quickly. But this style of maglock, these are used on like office doors around the world, and they are left on 24/7. To secure reception areas and of businesses everywhere. So these are normally pretty good for being used in something relatively trivial, like an escape room, something like that. So yeah, you shouldn't have too many problems with a well-made one. Certainly. I hope that answers the question. Let's have a look. Is it not permanently locking customers in rooms is bad for repeat business? Yeah, and there's been some awful stories in the news recently, and not related to maglocks, but it just makes sense. I'm not a health and safety person. I'm not going to pretend that I'm distributing knowledge that is legally compliant or anything like that. But just from common sense, you wouldn't lock someone in like that. I think that is probably all of the questions which I can see. So, there you go. That was a bit different. I hope that was kind of a slightly different format. It was hard to pick a time that was going to work for everyone, to be honest. I kind of went for this time because it's like middle of the day for me, and I figured hopefully some folks in America, it might be very early Sunday morning for you. Some folks in Europe, maybe it's evening for you, I don't know. But I'm very happy to do these again if they are useful, maybe cover different sort of material. Maybe I could do one each month, like, so I think I'll still put the project videos up as normal, but then maybe I could do like a live Q&A as well or something like that. Don't really know. But please let me have your comments if you found it helpful. I hope that's answered. Oh, quick one, bit random. Where are you based? I'm in Norwich, in Norfolk, beautiful Norfolk in the east of England. And it's, well, I say beautiful, it's clouded over a bit now, but US, I'm not in the US. What's my most accurate survey? Oh, hang on, so I've got some more questions. Okay, come on, we'll do a few more questions. Do you think a Wi-Fi module is needed with the Arduino? Okay, so that's an interesting question. No. And so I said right at the beginning, Arduino, kind of is a description used for a wide range of quite similar small microprocessor boards. And the thing they all have in common is that you can upload some software to them, and based on that software, they can control hardware in different ways. So your basic model Arduinos don't have any kind of network connectivity. They don't have Ethernet or Wi-Fi, but you can get add-on boards that very simply add on that functionality. Now Arduino, the style which I'm using here, uses an Atmel chip, which is, let's think, how old is it? 15 years old, probably something like that, which, is kind of ancient in some respects in these things. There are much newer devices, like first came the ESP8266, sometimes also called a WeMOS D1. And then there was the ESP32, which is a newer chip again, and you can program them using the Arduino IDE exactly the same way as we did today. You can use a lot of the same, although not always exactly the same libraries, and they have built-in Wi-Fi. They also have built-in, one of them has a built-in hall sensor, some of them have other extra little neat features, like a little OLED screen on the front and things like that. And they're very cool devices. I do still find myself using the vanilla Arduinos, though, as I call them, like this. No Wi-Fi, no extra bells and whistles. I find them pretty reliable, actually. There are people in Facebook groups that will say that Arduinos are, for amateurs and things like that, which I think is just nonsense. There's a bit of kind of friendly competitivism between people who use kind of things like this and people who use things called PLCs, which are like industrial robotic kind of machines that was originally developed for use in the automotive industry, I think in the US. And you can use either one to solve the same problems. They come at it from a very different approach. And as someone that's really into PLCs will say that Arduinos are kind of like toys, and people that use Arduinos a lot will say, well, PLCs are ridiculously overpriced pieces of industrial machinery that you really don't need if what you're trying to do is drive video displays and maglocks and things like that. But, it's cool. No, I don't think you need Wi-Fi. That was a really long-winded answer, wasn't it? It can be helpful in certain circumstances. It will drain your battery a lot quicker as well, though. So if you're creating portable props, I would go for the simplest processor that does all the functionality that you need it to do, basically. What's in Swartham? Who's in Swartham? Oh God, Carl, you're in Swartham. Don't believe it. I'm in for the Games Master to operate. Okay, I'm going to go servo. I've seen your question about servo. I'm going to come back to that. I'm for the Games Master to operate. Okay, so side project at the moment, sneak peek. I am working on something at the moment, which is a Games Master's kind of control panel system thing that runs on a PC. You might have seen, I did a video a little while ago about MQTT. And MQTT is a networking protocol which you can use to get different devices to talk to each other. and it works on Arduinos and also on other devices like Raspberry Pis and on PCs and on Android tablets and iOS and iPads and things like that. And something I'm working on at the moment is actually a PC-based control room software that will allow you to monitor those MQTT messages that are all being passed around between different devices. So, having said, so I'm now going to go back and completely change what I said. Having said that, I would normally use the device that has the that does, you know, the minimum amount of requirements of what I need it to do and nothing else. I will now just put a little disclaimer on that, which if you are running a permanent room, let's say, and you're actually investing in, you know, hardware that you're expecting to be used for some time and would like to reduce the amount of management ongoing from it, then Wi-Fi is something that actually, alright, it's going to cost you a little bit more to set it up, it's a little bit more complex to debug if it goes wrong, but the advantages you have potentially in terms of, so I've got my little device over here and no longer is it self-contained on a board like this. Actually, I can get it to trigger lighting effects, or I can get it to, you know, I can have a Games Master remotely override it, or monitor its status, or, you know, set it to a new mode and things like that. For that, Wi-Fi or Ethernet, definitely, I think we will see things going more that way. Really depends kind of where you are on your tech journey at the moment, I suppose. If you're starting from nothing, I would go to a device like this, and I still use an awful lot of these, and they're very good if you use them well, and you know, very reliable, and you can do loads with them. Really, when it comes down to it, like 95% of all escape room prop puzzles I've seen, when you look under the hood, basically look something like that. They've got slightly different inputs, slightly different outputs, but that basically is the template you could use for whole things. It's just how you dress them up and, you know, make them look pretty and sell them in a theme and a narrative and things like that. But yeah, if you're slightly further along your tech journey and you're looking more at that kind of fully automated room, zero reset, that kind of thing, that's where the Wi-Fi and the network connection can make a difference. And like I say, I've got something in the pipeline, but I'm not quite ready to share it yet that might be along those lines in the future. Love or hate, ruggedized is the term thrown about for the PLC argument. Yeah, yeah. You know, I have very limited knowledge of PLCs, so I'm not gonna diss them when I don't feel that I've got the experience. But in a sense, I don't see why I would pay £10,000 to install something when I have something perfectly reliable I can do for a couple of hundred. So I don't know. If you use a power supply for the Arduino, how many milliamps should it produce? Okay, so the Arduino itself, there's a question. I think with no load, so if it's got nothing else it's doing, and it's just sitting there processing the code that you've uploaded to it, you know, I don't actually know exactly how much that draws. I'm going to guess it will be around 100 milliamps, but I'm not sure that that's right. I've certainly powered them on a thing that's rated for 0.5 amps, and they've been fine for that. As soon as you start adding extra things that they're controlling, so you can draw up to 40 milliamps on each of the input and output pins, and I think the 5 volt output that you've got here, I think you can draw 500 milliamps on that. So to be safe, you'd probably want a 1 amp supply, but that's off the top of my head. I don't definitely quote me on that one, I'm not sure. Oh yeah, avocado, thank you. 1000 milliamps or 1 amp, yeah, thanks. You got there before me. Now there was a question a while ago about my servos as well. What's my most accurate servo? Okay, that's so. Just because we're doing like an introductory session, so we'll just briefly explain servos. So when it comes to making things move, which we often want to do in escape rooms, you've got a couple of different options. You've got, at the simplest extreme, you've got a DC motor. So motor, you connect to normally ground and let's say 5 volt if it's a 5 volt motor, and it will spin one way. If you connect your 5 volt and you ground the other way, it's going to spin the other way. Okay, that's a DC motor, nice and simple. You've then also got servos. So with a motor, you don't get to stop it at any point other than by removing the power. The servo is slightly different because a servo you tell to rotate to a given angle, normally between 0 and 180, and it goes that angle and stops. You've also got stepper motors. Stepper motors are more like the DC motors, but they don't just spin continuously. They rotate by a certain number of discrete steps, and they can be useful as well. And you've also got linear actuators, which are things that extend and contract. So servos, which is what the question was about. In terms of accuracy, I'm assuming your question there is in terms of, if you tell it to go to 65 degrees, does it go to exactly 65 degrees? That's not really something I've ever compared, if I'm honest with you. I pick different servos normally depending on their torque. So, if I want a servo to just knock open a small latch or something like that, or I've been doing a little bit with animatronic stuff recently. So if you're controlling a very light load, so moving some eyebrows on the model, you can get away with a very small micro servo, like a 9-gram servo that's got a very low torque. If you're moving any kind of serious hardware, I tend to go for more the heavy duty servos. So I use an MGS 995, I think it is my more heavy duty one I normally go to. In terms of accuracy, I genuinely don't know, I'm afraid. It's not something I've ever really had an issue with. This sounds like a buzz and chatter non-stop. Okay, so chattering with servos, I would say, so you've got a question about grounds already, and also make sure you have a sufficiently beefy power supply. So anything that moves typically needs a surprising amount of power. Any of those things I just mentioned, any servos, motors, linear actuators, anything like that. So you need a separate power from the Arduino. It has to be the right voltage, so the correct voltage. Servos are almost always 5 volts, and it has to have at least as much current. It can supply at least as much current as it needs to. There's no worry about using a bigger amount of current in your power adapter than what you're using, because the device will only draw as much current as it needs. So you can't kind of overload it with current. That's just the maximum it can supply. Coming out of the first interact Arduino and publish using a public email address I can ping on. Send me something through. Oh god, yeah, probably. Alistair at playful.technology. If you want to send me a private email, that's fine. I'll pick that up. Using the service to aim lasers. Okay, yeah. So I have a thing about. I do have a thing about lasers. Again, this is something that differs in different countries, so I'm not going to do a health and safety thing because what applies here might not apply where you are. Lasers in rooms, I have a bit of an issue with, partly because they're almost never as impressive as you think they're going to be. I think I grew up like watching films with lasers, that either like Star Wars type lasers or alternatively like a bank heist type laser, and you can see things across the room. And they don't normally end up looking as cool as that. You need to have a lot of haze or something in the room to even see the beams. And then if you get one in the eye and you're blind, I don't know. So I'm afraid I don't have an experience of moving lasers on servos, but I can understand why you're now asking the accuracy question. That would make sense. But yeah, I've got no experience of that, I'm afraid. Never power servos in the Arduino. Yeah, totally agree with that. You need a separate beefy power servo. You're very welcome. Right, I don't know. I don't even know what the time is. But that feels like it's probably about as much as I can say without endlessly repeating myself. So if you've made it through to the end, hooray! Thank you very much for watching. Hopefully you found that useful. Like I say, I might do this again in the future. Maybe occasionally, maybe if people have a particular thing that works better in this format than in anything else. I'm just pleased that the live stream appeared to work. As far as I can tell, it did. I have no idea. I can see these messages coming up the side, so I'm guessing I'm connecting with at least some of you out there. Thanks very much for watching, and I shall put up another project as normal. Will go up sometime in the next few weeks as well. So thank you and goodbye. And I'll try and find the end stream button. Here goes. Ooh, there we go.